In this video, I'm going to show you how to draw the graph of trigonometric functions. Okay, and we're going to study the domain and range of the trigonometric. So first, let me show you how to draw the graph of sine x. So domain of sine x is r, because if you observe the values of sine x, okay, there is no any value of x at which sine is not defined. Okay, so sine is defined at all points, so that's why. So domain is r means set of real numbers. Set of real numbers. Okay, so what will be the range? Okay, range, here you see, if you observe the values of sine x here, so sine 0 is 0, sine 30 is half, sine 45 is 1 by root 2, sine 60 root 3 by 2, then pi by 2 is 1, then pi is 0, then minus 1, again 0, plus 1, 0, minus 1, and those values, half and root 3 by 2, 1 by root 2, those are all less than 1 and greater than 0. And again you see, if you observe the values of sine x, you can see here at pi by 2 its value is plus 1. Okay, then again we are getting the same value at 5 pi by 2. Okay, at 5 pi by 2. Okay, first we have got plus 1 at pi by 2, that means at 90. Okay, that means at 90, then we are getting the same value at 5 pi by 2. Okay, so here the period, and that means its value is repeating after the interval of 5 pi by 2 minus pi by 2, that's equal to twice pi. Okay, so this is the period. So it is a periodic function and its values are repeating after twice pi. Okay, so now you see, if you observe the values of sine x carefully, then you can observe that all the values of sine x are lying between minus 1 to plus 1. Okay, and here you see, between these 2 points, pi and 3 pi by 2, between these 2 points, from 0 to minus 1, we are going to have the values of sine x which are less than equal to 0, greater than equal to minus 1. Okay, so observing the values of sine x, we can conclude that the range of sine x is close interval from minus 1 to plus 1. Okay, so all the values of sine are lying between plus 1 and minus 1. Okay, that means including these two also, plus 1 and minus 1. Okay, so now let me show you how to draw the graph of this function. Okay, sine. So let me clean the page first. Okay, so now here it is pi by 2. Okay, so let us observe the values of sine. Now again, here you see, at those points, at 0, pi by 2, pi, 3 pi by 2, twice pi, 5 pi by 2, 3 pi, and 7 pi by 2. At those points, the values are what? At 0, value of sine x is 0. So this is the point here. Let me draw the graph below. Yeah, so this is the point where sine x is 0. Then again, at 30 degree, let us take pi by 2, not 30 degree. At pi by 2, that means at 90 degree, its value is 1. Okay, its value is 1, so that's why at pi by 2 its value is 1. Okay, this is 1. Then again at pi it is 0. So at pi the sin x is 0, so that's why at pi it is 0. Then at 3 pi by 2, the sin x is minus 1. So here is the minus 1 on the graph. So at 3 pi by 2 it is minus 1. This is the minus 1, this point is minus 1, and here it is 0. At pi sin x is 0. Then at 2 pi, at twice pi, the value of sin x is again 0. So twice pi, here it is twice pi and it is 0. Then at 5 pi by 2, it is again 1. So here this is 5 pi by 2 and it is 1, its value is 1. So let me, at 5 pi by 2 its value is 1. Okay, here it is 1. Then at 3 pi by 2, at 3 pi value of sin x is 0, this is 0. So at 3 pi it is 0, this is 0. Then at 7 pi by 2 it is again minus 1, here it is minus 1. So let us join the dots. Okay, so that's how we will get the graph of sine, like this. Okay, so this is the graph of sine. Okay, so here you see at sine 0 we have got 0. At sine pi by 2, is plus 1, sine pi is 0. Then sine 3 pi by 2 is minus 1. Then sine twice pi is 0, again here plus 1, 0, minus 1. Okay, so I hope you have understood how to draw the graph of sine x. Now let's move on to cosx, how to draw the graph of. Now let me show you how to draw the graph of cosx. Okay, cosx. So what is the domain of cosx? So if you observe the values of cosx, you can see that like sin x, so at all the points of x, for all the values of x, cos x is defined. So we can say domain is R, set of all real numbers, and the range is same as the sign. Okay, so minus 1 to plus 1, that means all the values of cos x are lying between minus 1 and plus 1, including those two also. Okay, so now you see it is also a periodic function, and it repeats its values after the same interval twice pi. Okay, so here you see we are getting 0, not 0, we are getting plus 1 at 0. Okay, we are getting plus 1 at 0 degree, cos x is 1. Then again we are getting 1 here at 2 pi. Okay, at 2 pi, so interval is clearly 2 pi. So now you see, if you observe the values of cos x at all the points, those values are lying between minus 1 and plus 1. Okay, minus 1 and plus 1. So here also from minus 1 to 0, those values are greater than equal to, in this region minus 1 to 0, here the values are greater than equal to minus 1 less than equal to 0. Then again here in this region you can see from 1 to 0 values are less than equal to 1 and greater than equal to 0. Okay, so that's how we will get the values. Okay, So you can say, observing this pattern, you can say that the range is -1 to +1. All the values of sin x either equal to -1 or greater than -1, less than +1 or equal to +1. Okay, now let us draw the graph. Okay, so let us draw the graph taking these values of sin x. So sorry, cos x, not sin x. So here you see cos 1, cos 0 degree, cos 0 degree is 1. So that's why, so at x is equal to 0, cos is 1. So first point is here. Then at pi by 2, values of cos x is 0. So that's why here it is 0. So graph should be like this. Okay, then again at pi it is -1. Then at 3 pi by 2 it is 0. Then again at twice pi it is +1. Then at 5 pi by 2 it is 0 again. Okay, then at 3 pi it is again -1. Okay, then at 7 pi by 2 it is 0 again. So this kind of graph we will get. This is the graph of cos x. Okay, now let me show you how to draw the graph of tan x. Okay, tan x, we know that tan x is equal to sin x by cos x. Okay, and for cos x is equal to 0, tan x is not defined, and cos x is equal to 0 at x is equal to twice n plus 1 into pi by 2. At those points here you see, if you observe the observe the values of tan x, so it is not defined at pi by 2, it is not defined at 3 pi by 2, and not defined at 5 pi by 2. Okay, 7 pi by 2. At those points tan x is not defined. Okay, so what are the points? Pi by 2, 3 pi by 2, then 5 pi by 2, so 7 pi by 2. Okay, so those are all odd multiples of, that is twice n plus 1 into pi. So at those points cos x is equal to 0, so where tan x is not defined. So that's why we can say tan x is not defined at x is equal to twice n plus 1 into pi by 2, where n is equal to 0, 1, 2, 3, ... so on. Okay, that's why domain of tan x should be r minus this should be excluded, because here tan x is not defined. Okay, so we cannot take those points where tan x is not defined. So this is the range. Okay, so I hope you have understood this, and find the range. Okay, range of tan x. So what will be the range of tan x? So now again let us observe the values of tan x again. Okay, here you see the values of tan x from the point 0 to 90. If you observe the values of tan x from 0 to 90, the values of tan x are 0, 1 by root 3, 1, then root 3, then infinity. So you can say that those values are increasing from 0 to infinity, plus infinity. Okay, so between these 2 points, pi by 2 and pi, here you see, if you find 10 pi by 2 plus suppose 30 degree, okay, then it will be minus cos 30. Okay, minus cos 30, that's going to be equal to minus root 3. Okay, then we know that instead of writing, let us write pi by 2 plus x. Okay, pi by 2 plus x, so that's minus cos x. Okay, so at x is equal to, if you observe the value at x is equal to 30 degree, so cot 30, sorry, it is cot not cos, cot 30 is root 3, so as there is minus cot, so it must be minus root 3. Okay, cot x, cot 30 is root 3. Okay, so at x is equal to 45, it will be minus 1. At 60, it will be minus root 3 by 1 by root 3, it will be minus 1 by root 3. So then at pi value of 10x is again 0. Okay, again 0. So you can see this values are increasing to 0 from we know at pi by 2. At pi by 2, 10x is equal to, we know its value is not defined. Okay, so from 0 degree at x is equal to 0 degree to pi by 2, it is increasing from 0 to infinity. Then again from pi by 2 to pi, it is decreasing towards 0. Okay, so that means after pi by 2, we know that at pi by 2 its value is infinity. So you can say at pi by 2 its value of 10x is infinity. Okay, at pi by 2 it is infinity. So after that we will get the values will be decreasing from increasing from minus infinity to 0. Okay, then again 0 to plus infinity, then plus infinity to again minus infinity, like that. Okay, so that's why we can say the range of 10x is given by the open interval from minus infinity to plus infinity. Okay, so that is the range of 10x. Now let me draw the graph. Okay, let me draw the graph of 10x. Okay, so here you see at those points, so 10 0 is 0. We already got to know that 10 0 is 0. 10 0 is 0. So here is the point 0, and 10 pi by 2 is infinity. So at pi by 2 it is infinity, so the graph will be increasing like this at this point. At pi by 2, this is pi by 2, and the graph will be increasing like this, and these two are not going to touch. Okay, so it's going to be increasing like this. Then again at pi it is 0. At pi value of 10x is 0, and here it will be increasing from minus infinity to 0, like this. Then similarly at this point again we will get like this. Okay, so such kind of graph we will get. So cortex is equal to cos x by sin x. So here cortex will be not defined at if it will be not defined if sin x is equal to 0. Okay, if sin x is equal to 0, and sin x is 0 at those points. Here you can observe the values of sin 0 0, then sin pi is 0, then sin twice pi is 0, then sin thrice pi is 0. So you can see that at those points 0, pi, twice pi, thrice pi. At those points, values of sin x is 0. Okay, so we can say at x is equal to n into pi, sin x is 0, where n is equal to 0 dot 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 0 1 2 3 dot 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 so on. Okay, so that's why domain will be r minus n pi. So domain of cortex must be r minus n pi. Okay, so we can write domain of cortex, the function cortex. So domain is r minus n pi. So this is the domain. So what will be the range? Range will be same as 10x, that is open interval from minus infinity to plus infinity. If you observe the values of cortex, then you can find the range easily. Here also like 10, so values are lying between this interval, lying in this interval. Okay, and its graph, so as you can see, the value of, let us observe the values of cortex at those points here. Let me show you here. Cortex at so at 0 degree, cot is infinity. At pi by 2, it is 0. At pi, again infinity. At 3 pi by 2, again 0. Okay, so at 0 it is infinity. Okay, so at 0 it is infinity, so we will obtain such types of such kind of graph like this. So it is not going to touch the y-axis. Okay, so then again here you see, and at pi again it is infinity, that's why it comes like this. Then again we will get this sort of graph. Sorry, this is twice pi. At twice pi it is infinity, at pi it is infinity, so we will get like this. Similarly, so this is the graph representing cortex. Okay, so hope you have understood this. So now let's move on to next function. Now let me show you how to draw the graph of secx. We know that secx is equal to 1 by cosx. Okay, so if cos x is equal to 0, then sec x is not defined. Sec x is not defined. Okay, and the points where cos x is equal to 0, we know that we have already discussed. At x is equal to twice n plus 1 into pi by 2. At those points of x, cos x is 0. So that's why the domain of sec x, domain of sec x must be equal to r minus twice n plus 1 into pi by 2. So what will be the range of this? First let us study the range of cos x. Range of cos x. So what is the range of cos x? We know that range of cos x is equal to from minus 1 to plus 1, interval from minus 1 to plus 1. So now you see, from minus 1, then we will go to, after minus 1 we can write next point is suppose 0 minus 0.9, then minus 0.8 dot 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 so on, then 0, then again we will get 0.1, 0.2 so on, then again 1. Okay, these are the points. Now you see, minus 1 minus 0.9 means 9 by 10 you can write, and 0.8 means 8 by 10 you can write. Okay, then 0, then 1.1 means 1 by 10, then 2 by 10, and so on up to 1 we can write. Okay, between 1 and -1 there are infinite numbers. Okay, so now you see, we know that secx is reciprocal of cosx. Now let us take the reciprocals. If you take the reciprocals here, as cos x is reciprocal of sin x is reciprocal of cos x, so take the reciprocal of the range of the cos x. So then what will happen? So then you will observe that now you see reciprocal of -1 is -1. Okay, reciprocal of -9/10 is 10 by -10 by 9, which is less than -1. Then similarly you will get the reciprocal of -8/10, which is -10 by 8, which is again less than -10 by 9. So up to we will get -infinity. Then we know the reciprocal of 0 is infinity, so that's infinity. Let us write here. So then here you see +1, reciprocal of 1 is 1. Then reciprocal of 2 by 10, reciprocal of 2 by 10, reciprocal of 2 by 10 is 10 by 2, which is equal to 5. 5 is greater than +1. Then reciprocal of 1 by 10, reciprocal of 1 by 10 will be 10, which is again greater than 5. So it is moving towards infinity, plus infinity. So from these values, if you observe these values, so these are the range of secx. Okay, so we can say the range of secx is given by -1, here it is close, up to -infinity, it is open interval, union +1 to +infinity. Here on this side it is open interval. So hope you have understood. Let me write here clearly. So we can write range of secx is equal to, we can write -infinity to -1 to -infinity. Here this is here close interval, -1 is closed and here open at -infinity, union, then again close interval from 1 to +infinity, so here open. So this is the range of secx. Okay, now let us draw the graph of secx. So here you see, if you observe the values of secx at 0 degree, sec is 1, at again pi by 2, at 90, that means at pi by 2 it is infinity. Then at again pi it is -1. Then again at thrice pi by 2 it is infinity. At twice pi it is 1. At 5 pi by 2 it is infinity. At thrice pi again it is -1. Okay, so if you observe this value, then we will get that at 0 degree sec x it is 1, at 0 it is 1. Then at pi it is infinity, so we will get such kind of graph. Okay, at pi by 2 it is infinity, so we will get this kind of graph. So it will increase from 1 like this. Okay, so again at 3 pi by 2 also it is infinity. At 3 pi by 2 also infinity. At pi by 2 it is also infinity. So at pi it is -1. So on this side we will get, so first So let me clean this. So let me write the range of sec x here. So what we have got, range of sec x, we have got -1 to minus infinity, then union, then +1 to plus infinity. So this is the range we have got. So now let me draw the graph of then sec x. Okay, draw the graph of sec x. So here you see we will get such sort of graph here. If you observe the points of sec x, so at 0 degree sec 0 is 1, then at pi by 2 it is infinity, then again -1, then infinity, then +1, then infinity, again -1, then infinity. Okay, so here at 0, at this point, at 0, x equal to 0, the sin x is 1. So here sin x, so not sin x, sorry, sec x is 1 at x is equal to 0. So then at pi by 2 it is infinity, so this graph will be raising up. Okay, then again here you see at pi it is -1, at pi it is -1, here it is -1, at pi it is -1. So we will get this sort of graph. Then again at twice pi, at twice pi it is +1, at twice pi it is +1. So here we will get this kind of graph. Okay, then again at thrice pi, here it is -1, so here we will get this like this. So this is the graph of sec x. Okay, so hope you have understood how to draw the graph of sec x. Now let us draw the graph of cosec x. Okay, now you see, cosec x is equal to 1 by sin x. Okay, 1 by sin x. So cosec x, it is not defined when sin x is equal to 0, and sin x is 0 at x is equal to n pi. Okay, at n pi. Okay, so here domain of cosec x will be r minus n pi. Okay, so this is the domain of cosec x. Okay, this is the domain. So as I have shown how to find a range of the sec x, similarly we can find the range of the cosec x. Okay, so we have to use the same method. Okay, we can proceed the same way as we did in case of sec x. So, and the range of cosec x is also same as sec x. Okay, range is from -1 to minus infinity. On this side it is open interval towards minus infinity, union, then again +1 to plus infinity. Here it is interval. So this is the range. Okay, same as sec x. So the pattern of the graph will be similar, but not exactly same. Here we will compare the pattern of the graph of these two, cosec and sec. Here you see in case of cosec x, okay, at 0 cosec is infinity, so we have to start like this. At 0 it is infinity, so it should be like this. Okay, at pi by 2, here if you observe this, at pi by 2 it is 1, here is the 1, and again at pi it is infinity, at pi it is infinity. So here again it will be goes on increasing like this. These 2 points not going to touch each other. Okay, so here these 2 points not going to intersect. Okay, so now again next is this is -1, so 3 pi by 2, that's -1. So here is the -1, so here the graph will be like this. First let me draw this dotted line here. So here we will get such kind of graph. Okay, so similarly we will get, so that's how we can draw the graph of cosec x. Okay, so I hope you have understood this, how to draw the graph of trigonometric functions. In the next video I'm going to show you how to find the general and principal solutions of trigonometric equations. Okay, so hope you like the video, and please subscribe my channel and do share my videos. Thank you for watching.